Hi everyone. Welcome back to my channel, and today we will be talking about the third generation. Since we have already discussed about the first generation properly, also the difference between the first generation, second generation, as well as second generation city. So now we are moving towards rotate, that is the third generation city. So in the year 1975, there was a company called General Electric Company, which was introducing a CT scanner in which the translatory motion was completely eliminated. So there was no translatory motion in rotate. That can be the first question, which there is a possibility of CRE question. Here, only rotatory motion was required, with both the X-ray tube and the detector rotating around the patient. Means what is the configuration between the X-ray tube and the detector? Was both were rotating around the patient. The scanning geometry was having fan beam. Fan beam was introduced in second generation only. So this is not new, but still fan beam, what is the characteristic of fan beam? It will take less time and give you more data, right? That was the basic function of fan beam. That was very important and that was very useful for us. So third generation geometry will be the fan beam geometry, right? And the original unit could produce a scan in around 4.9 seconds, and they are talking about the scan. Got it? They are talking about the scan. So multiple detectors were aligned, right, along the arch of a circle, right? So along the arch of a circle, that gantry road, round gantry, along the arch of a circle, there were multiple detectors whose center, just listen to this point very carefully. Whose center means if this is an arch and this is the center, so they will focus on a focal spot that is fixed, and that is called isocenter, right? So the detectors are always perfectly aligned with the X-ray tube. The X-ray beam is collimated further into a fan beam. Why this is collimated? Give me the function of collimation. Tell me the function of collimation in the comment section. Okay. Then we will talk about here both the X-ray tubes and the detectors will rotate about the patient. That is, they are having rotate geometry in concentric circles whose center approximately will coincide. Listen to this point very carefully, very important for CRE, right? So they are in concentric circles whose centers approximately coincide with the center of the patient, as illustrated in the figure. So original rotate scanner used 288 detectors, but newer versions of some unit use over at least 700 detectors. Got it? So the fan beam must completely cover the object to be imaged. And here both the xenon and the scintillation crystals detectors can be used in this configuration. Okay, so we are using both the crystals, xenon also, or scintillation crystal detectors also. So both can be used. And why this both can be used? Because the detectors sorry So because the detectors and the X-ray tube are in precise alignment, that is why you can use both the kind of detectors. Got it? Then one more point we are having is, in the original rotate scanner, the X-ray tube was pulsed. So what they have told you just now is, original unit were having X-ray tube was pulsed, and each of the pulse of the tube produced one projection. Got it? And the number of scan lines in each projection was equal to the number of detectors. Listen to this line very carefully again. Okay, again listen. The number of scan lines in each projection, was equal to the number of detectors. A single image is computed from many projections, often more than 1000 projections. And in some rotate scanners, the X-ray tube is continuously on, and individual projections are obtained by reading output of the detectors at rapid interval. This line is actually very important. You might not be feeling very conscious right now, but yeah, this point is very important. In some rotate scanners, the X-ray tube is continuously on, and each of the projections are obtained by reading the output of the detectors at rapid intervals. Okay, so this is a very important question for your CRE exam. Okay, while reading again, see, whenever I am teaching you why this video, now always open the PDF. Okay, because this video is not having the PDF, I am not showing that. The topic of the number of projections and the number of individual lines in each projection will require more attention. See, rotate or so called, you can say sorry, third generation scanners continue to produce excellent images. That we already know. That is why we are using third generation geometry, right? Even today also we are mostly having third generation geometry. So excellent images with short scan times, and this will emphasize that the point that third generation units are not better or worse than fourth generation units. That is why we are still using, in some places we are still using the third generation. We wish to be certain that our use of the terms line, projection and CT image, they are not creating confusion. Obviously the CT image is the image of one CT slice that is viewed on a TV monitor or on the film that you might be seeing in the console room, right? Image is computed from many projection. Whatever CT image you are viewing is composed of many projections, right? And a projection is produced each time the detectors are read, right? Each of the scan line, right? So therefore the data contained in a projection is a set of reading composed of one signal from each detector that has been exposed to the X-ray beam. So whatever projection is producing each time the detectors are read, the data contained in the projection is a set of readings. Okay, is a set of reading which is composed of one signal from each of the detectors. So many detectors, so many signal, and those many signals are then producing the data which is required to form the CT image. Got it? So we describe the data we are describing it as signal. Got it? Collected from one exposed detector. Signal means signal is your you know what, one line again you can write it somewhere. The data, that is the signal collected from one exposed detector, is called as a line, or you can say scan line. Okay, so this is the difference between the three, and this is very important, again I'm telling you. So this means that one projection contains many scan lines, and the number of scan lines is equal to the number of detectors exposed. Number of scan line equal to the number of detectors exposed. Unfortunately, the terms are sometimes obviously very confusing. For example, the final image of one CT section may be called a scan, or a slice, or an image. That you can leave. You have understood the difference between the three now, so you can just write it somewhere and paste it on the wall. Okay, so this is this much is okay for the rotate geometry, and I've given you many questions before starting CT only. So I would request you to please go through those questions again while reading, while going through these videos. Okay, thank you.